next is in this problem, the post tensioning concrete beam of 200 mm wide and 450 mm deep is a pre-stressed by a circular cable. The total area is around 800 mm square, with the zero eccentricity at the ends and 150 mm at the centers. The span of the beam is 10 meter, and the cable is to be stressed at the one end. Okay, such that initial stress of 840 Newton per mm square is available in the unjacked end immediately after the anchoring. So determine the stress in the wires at the jacked end and the percentage of the loss of the stresses due to the friction. So coefficient of the friction of the curvature effect, it is given as 0.6, and friction coefficient for wave effect is 0.003 per meter. So this is what the question they are given. First, what you have to do is, for the radius of the circular cables, then you have to use the equation. That equation is r minus 0.015 whole square plus phi square is equal to r square. Okay, so this is the equation which I am showing here. Okay, which I am showing here. So this equation you have to use it in this. See here, in this you have to use here. See here, this is the equation, this one. Okay, which I am showing here. This is what the equation you have to use it. Okay, in this. So this is the equation, r minus 0.15 whole square plus phi square is equal to r square. So you have to do a trial and error. So what you do is you put r is equal to 20 and try to do it. So right hand side should be equal to left hand side. So every time put 10, 20, 30, 40 like that, you try to do it. See what is the variation from right hand to left hand side. Okay, when it is varies to smaller value, try to bring around some around nearest to that. So it will sometime it will consider it is get around 80 means, then you go for 81, 82, 83 like that. So insert the value of a r to above equation 81, 82 like that. So the when r is equal to 84, right hand side is equal to left hand side. So such that the radius of the circular cable is around 84 meter. Okay, so this is how you have to find out the radius value. Okay, so next I will go for the further. Okay, see here, next the whatever the angle between the horizontal and the tangent drawn to the cable of the supports, then it will be given by the sin alpha is equal to 5 by 84. What is this 5 is? That is the half of the span. Okay, the total span of the section, it is being given 10, but angle will be taken at the half of its length. So that's why. Okay, the radial distance will be 84. So that is nothing but opposite by hypotenuse. Opposite is 5, hypotenuse will be 84. Okay, so 5 by 84 is the half sine of angle that you will get it around. See here, for this one you will get around 5 by here what I'm showing here, 5 by 84 is there now. So that is the sin alpha is equal to 5 by 84. That is the angular. Okay, so that is opposite by hypotenuse. So you will get around 0.6 radians. Okay, next what you have to do is, after finding that, then you have to find out the cumulative angles. So cumulative angles will be twice of the sine of angle. Okay, so sine of angle, it is around 0.06 radians. The angle between the tangent will be twice of that sine of angle. So that finally you will get it around the angle between the tangent between the cables is 0.12 radians. Okay, so initially px initial stress in the jagged end, that is given as 840. It is, you can see here, 840 840, you can see it here. Okay, initial stress they are given, sorry, stress at the unjacked end, that is given as 840. Initial stress at the jacked end, it is P naught. Okay, so you know general equation, Px is equal to P naught into 1 minus mu x, k alpha into k alpha plus mu x. Okay, so that is the formula. So that is the formula which is being used. I will repeat once again. Px is equal to P naught into 1 minus mu alpha plus kx. That is the formula which is being used. It is not been written here. Okay, so I will write it here. Okay, so mu alpha, mu alpha plus, sorry, plus k into x. Okay, this is the formula which is being used. Mu value, it is being given in the question, so that value only will be taken directly. That has 0.6, that is the coefficient of the friction of the curvature, that has been taken as 0.6, and 0.12, so that is then what the alpha value. Okay, alpha value we have determined cumulative angle, that is 0.12. Okay, so k is a that is the value which is been given in the question, that k is nothing but coefficient of the friction for the wave effect, that is 0.02 here, 0.02 here. Okay, 0.003 per meter. Okay, coefficient of friction of the wave effect, it has been given, so that is the k. Okay, x value is nothing but the length of the section. Okay, length value, here it will be given as 10 meter. Okay, take it as 10 meter. So that you substitute the value. Okay, you can see here the whatever the here I'm showing here, this 10 value, that is nothing but the length of the section, that is 10 meter. Okay, so finally if you simplify this equation, finally you will get it as 0.898 P naught. Okay, so P naught is the initial stress. Okay, so finally what you do is P naught, P naught you keep it as it is, and 0.898 you bring it towards the down. Okay, so we know that Px, the stress at the unjacked end, it is 840. It is being given in the question here. Okay, 840, that Px value substituted. So finally P naught is equal to 840, 840 divided by 0.898, you will get it. So if you simplify that, you will get the finally 940. Okay, initial stress as for that the stress at the unjacked end, it will be initial stress will be 940 Newton per mm square. Okay, so next is the loss in the stress. Okay, so one is the initial stress, and another is the one is initial stress, another is the stress at the unjacked end. So you want to take the difference between this, then you will get the loss of the stresses in the cable. Okay, the loss of the stresses in the cable is equal to, so initial stress it is 840, sorry, 940. Initial stress is 940, and the stress at the one end in the initial stress, it will be for the unjacked end in the anchorage, that is 840. If you take the difference between these two, you will get the loss of the stresses in the cable. Okay, so that is 940 minus 840, so you will get the 100 Newton per mm square. Okay, here 100 Newton per mm square is the loss of the stresses in the cable. Now you got the loss of the stresses in the cable, that is 100. Okay, so loss of the stress is 100, loss of the stress is 100, the initial stress is 940. Here initial stress is 940. So if you take these two, and you have to find out the percentage of the loss. Okay, so loss is the around 900 Newton per mm square, and initial stress is 940. The percentage of loss will be 100 divided by 940 into 100. So which you can see it here. Okay, here 100 divided by 940 into 100. If you do that, you will get the percentage of the stresses, percentage of the loss of the stresses. So that is 10.6 percentage. Okay, so this is how you have to find out the percentage of the loss. Okay. So this is for the loss of the pre-stressing in the steel.